So in this video I am going to show you another way of conducting or converting non-stationary datasets into a stationary datasets. In this case I am going to consider seasonal differencing. So seasonal differencing is the difference between an observation and the previous observation from the same season. So for an example, when you consider the monthly sales of the April per se, then you are going to consider the same season in the last year. For an example, if you consider 2021 May, for seasonal differencing you will consider 2020 May, so that it helps us to remove the trend, and once the trend is removed, you can convert the non-stationary dataset into the stationary time series dataset. So for this example we have to get these three libraries, and for this example I am going to select the stock market value of the Facebook from the starting date on 2012 to 2021, and in here I have mentioned the frequency as 12 because we know we are considering a monthly dataset for the Facebook stock dataset. So if you run the plot, you can clearly see an increase in trend in the particular stock market datasets, and if you check the ADF test and see whether the dataset is actually stationary or non-stationary, you will see that the p-value is greater than 0.8, which means it is greater than 0.05. Therefore we can agree that with the null hypothesis, which is this particular dataset is a non-stationary dataset. Therefore we can work to converting into a stationary dataset. So for that, as I mentioned before, I am going to use a seasonal difference method. So we can create a variable However, before you do that, you have to calculate the number of differences that required to conduct this seasonal differencing. So for that, you can call the ndifs function and run this variable. So in here you can see the number of differences is mentioned as 1. Therefore we can conclude that the differences is 1 to use in the difference algorithm. So now let's create a variable. So you have to give the particular data set and give the frequency, and the number of differences, which is 1. So now let's plot this. So now you can see data has become quite stationary. By looking at that, you can see whether there is a upward or downward trend by looking at the data set. So we can also check this by calculating the conducting the ADF test. So now you can see the p value is smaller than the printed p value, so which means we can agree with an alternate hypothesis and conclude the particular data set is stationary. So there are certain instances that we come across even after doing the seasonal differencing, the data set or the ADF test still agrees with the null hypothesis, which conclude that the data set is still non-stationary. In these situations, we have to call the regular differencing function, which we have done in the previous video.